Question 17. Here are two closed containers. 4 tennis balls just fit in each container. Each tennis ball has a diameter 64 millimeters. The boxes are a cuboid and a cylinder. Which container has the smallest surface area? You must show your working. To calculate surface area of a 3D shape, you have to look at the area of each of its faces. So we'll start with the cuboid, as this is one of the simplest sets of calculations. To work out the surface area of a cuboid, we have to realise that there are 6 faces to actually calculate. It's a good idea to try and name these to give it something that you would recognise. I personally prefer to call these the front and the back, the left and right, and the top and bottom. These are just descriptive ways to name the different faces of the cuboid, so I know which one I'm trying to work out and make sure I don't duplicate anything. To calculate the area of the face of a cuboid, we have a rectangle, which is found by multiplying the height by the width. Because we're told that each tennis ball is 64 millimeters across, which is the diameter, we know then that the box must be 64 millimeters tall, twice 64, which is 128 millimeters across, and the same in its depth, 128. To find the area of the front of this box, we multiply 64 by 128. In a cuboid, the front and back are identical, so this would also be 64 multiplied by 128. To find the left and right hand side, we see that it's also going to be 64, because it's 64 tall, multiplied by that 128 depth. So this will also give us the same calculation of 64 multiplied by 128. Both the left and right are identical, so have the same calculation. To find the area at the top and the bottom of the cuboid, we use the width, which is 128, and the depth, which is also 128, to give us 128 multiplied by 128, and the bottom must also be the same. Sometimes people will just calculate the front, side and top and double it. This will also give you the same answer. 64 multiplied by 128 gives us 8,092. 192, sorry. Which will be the same for all of these other sides. For the top and bottom, 128 multiplied by 128 gives us a value of 16,384, which must be the same at the bottom. If we add all those values together, we can find the total surface area of the cuboid. Add 8192. Add 8192. 8192. 8192. So we've added each of the 6 faces together to give us 65,536 millimeters squared. Now to calculate the surface area of the cylinder, which is a little bit trickier as it requires us to remember 2 simple formulae. In much the same way that we looked at the cuboid, we can write down each of the faces that we're trying to calculate. On a cylinder, we have 2 circles, a circle on the left and a circle on the right. Then we have the curved rectangular surface. If we rolled this out like a tube, we would end up just with a rectangle. Starting with the circles, we need to remember the first circle formula, which is that the area of a circle is equal to pi multiplied by the radius squared. For our circles, the radius is going to be half the diameter. So we multiply pi by half of 64, which is 32 squared. Let's work this one out first. 32 squared multiplied by pi. If you don't have a pi button, use 3.142 as a rough approximation. This would give us an area for our circles of 3,217.4 millimeters squared. And because the left and right must be the same on a cylinder, this will also have exactly the same calculation and therefore the same area. For the rectangle, we have the same idea as the cuboid, that we can multiply the width, in this case 4 lots of 64, which would be 256, and we need to multiply it by the width, which would be the circumference of the circle, the distance all the way round. The circumference of a circle is calculated by multiplying pi by the diameter. So we have 256 multiplied by the diameter of 64 and multiplying it by pi. Once again, if you don't have a pi button, you can just use 3.142. Giving us a surface area of the rectangular curved edge to be 51478 millimeters squared. The total of the cylinder then would be this number, add the two circles, 3217.4, add 3217.4, giving us a total surface area of 57,913.3 millimeters squared. Now the question said, which container has the smallest surface area? So just make sure that you do answer this question by pointing out that the smallest surface area is obviously going to be the cylinder, with only 57,000 millimeters squared compared to the 65,000 on the cuboid. You are allowed a certain degree of error depending on where you've rounded and what value you used for pi.